Okay, so in lesson 6, we are going to be talking about literal equations, and these are just equations that have multiple variables. Remember, variables are letters. So in these equations, you're going to see a lot less numbers and a lot more letters. Everything that we did in like the first 5 lessons, there was only one variable, right? It was just X or just Y or just R or whatever. Well, now we're going to have multiple letters all in the same equation, okay? But like with traditional equations, literal equations are also going to use inverse. We're going to be using inverse operations to isolate whatever variable we're trying to get by itself. So really with literal equations, it's less like solving and more like we're just rearranging. Like we're going to take your bed from one side of the room and put it on the other side of the room. We're going to put your dresser on one side to the other. All we're doing is rearranging, okay? Formulas are a great example of literal equations because they have multiple variables. So really quick, let's brainstorm. Let's list at least 3 literal equations that we've seen or used before. So what are equations that you've used or seen that maybe just have multiple letters? We've already even used some already this year. Those are variables, but what's maybe an equation that you've seen that has multiple letters in it? I feel like you're thinking maybe the Pythagorean theorem. A squared plus B squared is equal to C squared. Yes, that has 3 different variables, A, B, and C. Okay, that's good. Who can think of something else? Another equation that has multiple letters. No, like one that you've actually used before, not just like a random one you're making up. Again, I said formulas are a great example.
E equals MC squared.
You've used that before? Where? Yes. She said E is equal to MC squared. Yeah, that's right. What's another one? Because there's 3 letters in this one too.
AX squared plus BX equals C, or plus C.
What is that? Not one you're just looking through to find. Did you have one?
Axis of symmetry.
Y equals MX.
Oh, I love it. Yes, Y equals MX plus B.
Good job.
How many times did you guys use that last year? So much. Guess what? We get to do it again this year too, so woo woo. Okay, those are 3 great examples of literal equations. So now that we've done that brainstorming and we got through that, this table we're going to complete before we try some more on our own, but this table gives you a pair of equations. On the left side, I've given you like a real traditional equation that you're used to solving. And then on the right side, I've given you a literal equation that's going to use the exact same process to isolate whatever variable that it's looking to isolate. So let's look at this first equation, which is x plus 2 is equal to 10. So if I'm solving for x here, here's my x. I want to get x by itself. The only other thing over here on the left with x is plus 2. So how do I undo plus 2? All right, so I subtract 2 from both sides. X is equal to 8. So that's a traditional equation that you guys are very comfortable with solving. Now, here's the literal equation that says m plus n is equal to p. And we are solving this for m.
What is it? 1, 1, 1?
The coefficients, yeah. But we're not necessarily worried about that. What we're worried about, just like over here, I wanted to get x by itself. X was being added by 2. So over here, I want to get m by itself. M is being added by n. So subtract n. And the beauty of this, because it's letters and they're not like terms, because remember, like terms have the same letter, there's no math to be done. I'm not combining anything. I'm just rearranging like I said before. So M is equal to P minus N. And that's it. You've just rearranged that equation and you've isolated it or solved for M. So all you're doing is moving things from one side of the equal sign to the other using inverse operations. All right, let's look at the second example. Here's your traditional equation. 144 is equal to 4x. So here's my x. This time it's over here on the right, but x is being multiplied by 4. So how do I undo that? Okay. So I divide both sides by 4. And 144 divided by 4 is? 36. So 36 is equal to x. Okay. On the right side is our literal equation, which says d is equal to e times f. And it says solve for f. So all that means is I want to get f all by itself over here on the right side of the equal sign. So what's over here with f? E. And because they're glued together, that means multiplication, because that means e times f. So I undo that by dividing. So I divide both sides by e. So, and I can't simplify it. It's just d divided by e is equal to f. That's it. I'm just moving the letters from one side of the equal sign to the other using inverse operations. All right, so two more where we're going to do a little side-by-side comparison, and then we'll just try some more. We have 13x plus 9 is equal to 100. So here's my x. X is being multiplied by 13, but then we're adding the 9. So what do we undo first? Good, so we always undo addition or subtraction first. So we undo the plus 9 with minus 9. So we have 13x is equal to 91. And now our last step is to undo that coefficient. So since x is being multiplied by the 13, we divide. X is equal to 7.
Would that be the same thing? Like, if it said solve for x, would that still be the same equation?
Solve for x. We just did solve for x. So the second equation, we have 3x plus 2y equals 10. This time, it tells us to solve for y. So what that really means is just get y by itself. That doesn't necessarily mean, like with this traditional equation, we found the exact value that y equaled, or that x equals 7. When we're solving for y over here, because it's a literal equation, we're not going to get to say like y equals 2. But we're going to solve for it because it's going to be by itself. It's going to be isolated over here on the left because we're going to move everything else over to the right. So y is being multiplied by 2, and then we're adding this 3x. So just like we undid this addition first in the traditional equation, we need to undo the addition first in this equation. So the first thing we're going to do is bring this 3x over to the other side. And again, this 3x is being added. So we are just subtracting 3x. So that we are left with 2y is equal to, once again, these are not like terms. So I'm just going to rewrite it as negative 3x plus 10. I still have both terms over there. Or you can have 10 minus 3x, however you want it. I just like it to look like y equals mx plus b. So then now, all I have to do to get this y by itself is undo the multiplication. So now I'm going to divide by 2. y equals, we have two terms up here. Remember, terms are separated by plus or minus. We're dividing them both by 2. Negative 3 divided by 2 is going to give you a decimal. So if that happens, we're going to just leave it as the fraction. So we're going to leave this as negative 3 over 2x. And then we can do 10 divided by 2, which is... So this example, we got to rearrange and simplify a little bit because there were some numbers. If there's no numbers, you don't have to worry about doing any of that simplifying. You're literally just moving it over. Okay? All right. So we're going to do a couple more. What we're going to do is, we'll do 1 together, and then I'll have you try 4. And then we'll do 2, and I'll have you try 5, because they're kind of similar, stacked. Okay? So here we go. Number 1 is similar to what we just did. We've got 7y plus 4x is equal to negative 3. And we're solving this one for y. So just like before, y is being multiplied by 7, but we're also adding this 4x. Just like we talked about with traditional equations, we said you always undo the addition or subtraction before you'd undo this multiplication. So we need to undo this plus 4x first. So we're going to bring this 4x over to the other side by subtracting it. So that now I have 7y is equal to negative 4x minus 3. Those aren't like terms, so I can't combine them. So then the last thing I have to do to get y by itself is divide by 7. So we'll divide both sides by 7, which means y is equal to 4 or 3 are not going to be divisible by 7. So that's good. We can just leave them as the fraction. So we just do negative 4 over 7x minus 3 over 7. So both terms get divided by 7, but since they can't, we just leave them as a fraction. Yes?
Wait, what did you say about how you putting a negative 3 and put it over 7? Like how you going down 3 and put it over 7?
Well, because this y was being multiplied by 7, so then I had to undo this multiplication by dividing. But if I divide this side by 7, I have to divide this side by 7. And then what I was saying is these aren't going to, if I did negative 4 divided by 7, you're going to get an ugly decimal in your calculator. If I do negative 3 divided by 7, same thing. You're going to get an ugly decimal. So instead of actually doing the division, we'll just leave it as a fraction because we don't want ugly decimals in our problems. Okay? All right. So now I'm going to give you about 45 seconds. And I want you and your partner to try number 4. So you are solving for y. You've got 6x plus 2y is equal to 10. So about 45 seconds. Good job. Don't bring over just you're bringing over the whole entire 6x. It doesn't matter where you put it, but you're not just subtracting the coefficient. You need to bring the whole term over to the other side. That's why this vocab in this unit is so important, because when I say things like term and coefficient and all that, you have to know what I'm talking about. Except you forgot your x. But yes, other than that, it looks good. Yes. All right, so what did we do first here?
Subtract 6x.
Good. We are subtracting 6x first. So that we are left with 2y is equal to, I'm going to put the negative 6 in front. If you put it behind the 10, that's fine. Now, all I have to do to get y by itself is divide by 2. Very good. Which means y equals negative 3x, because negative 6x divided by 2 is negative 3x. And then 10 divided by 2 is 5. So negative 3x plus 5. Yes. Minus 3x. Yes, you can. Yep, if you have these terms flip-flopped, that's okay. All right. Number 2. It says solve for d. So I have s is equal to d divided by t. Listen to what you just said, or I said. D divided by t. So how do I get d by itself? Multiply, because if it's d divided by t, I undo division by multiplying. So I multiply both sides by t so that they'll cross cancel. And then you can leave this with this dot notation if you want, or if you want to make them like glued together like we normally see. So s times t is equal to d, or d times s, or s. The order doesn't matter. You can have t times s or s times t. Okay, so number 5, similar with an added little twist. So you and your partner take 45 seconds. So we are solving this for e. Ask yourself, what's being done? And then undo it.
Would we divide?
Uh-huh. That's the first step. Okay, a lot of us did a really good job with the first step. We were like, I gotta get rid of this denominator. So I need to multiply by n since it was divided by n. So then I have a times n is equal to 9e. Well, then again, just ask yourself, 9e, what does that mean? That means 9 times e. So I need to do the opposite of times, which is to divide. So then I divide by 9. So I have a times n divided by 9 equals e. Just like that. No math to be done. Just moving things around using those inverse operations. That's why I always say, like, ask yourself what's being done and then undo it. Okay? Last one. Nice and easy. I is equal to PRT. And we are solving that for t. Like I just said, ask yourself, what's being done to t? It's being multiplied by what? By p and r. So let's undo being multiplied by pr by dividing by pr. So that I have I divided by PR is equal to T. I just moved the PR from one side to the other using inverse operations. All right, 45 seconds for this last one. You are solving the equation for V. You have D is equal to V times R. I feel like we don't need 45 seconds. If I want to get V by itself and I ask myself, what's being done to V? V is being multiplied by R. So I have to undo that. So I'm going to do the inverse of multiplication. I'm going to divide. D divided by R is equal to V. Just like that. You're done.